Hello students, good time to all. I am Chandan Khan Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss Dirichlet conditions. What is Dirichlet conditions? Dirichlet, the mathematician who proposed so many conditions regarding a function, is either expand in terms of Fourier series or not. What are the criteria by which a function can be easily explained, or we can express that function in terms of Fourier series? What are these conditions? The function must be periodic. Another condition, it must be single valued and continuous. Except at finite number of finite discontinuities. Condition 3, it must have finite number of maxima and minima within a period. These three are the Dirichlet conditions for that of function is either we can express in Fourier series or not. The conditions are: the functions must be periodic. Since it is periodic, it has finite number of maxima and minima, and it is single valued and continuous, and except at finite number of discontinuities it has. Then at the point of continuity, the function converges, but at the point of discontinuity, how we evaluate that function? At point of discontinuity, let the function f of x is discontinue at a point x naught. Then the Fourier series converges to the arithmetic mean of the left hand limit and the right hand limit of that of function f of x at x naught. X naught is the point at which the function is not continuous, that is discontinued point. Then we evaluate that function f of x is equal to at x naught, that is f of x naught, that is the arithmetic mean of left hand limit and right hand limit, that is f x naught minus 0 plus f of x naught plus 0, arithmetic mean, that is divided by 2. This f x naught minus 0, that is left hand limit, and here that term is right hand limit, that is f x naught minus 0, that is the left hand limit of f of x at x naught. Here f x naught plus 0, that is the right hand limit of f of x at x naught. we evaluate that function at the point of discontinuities. These are the conditions that are named as Dirichlet conditions. Now we take an example regarding the Fourier series by using Dirichlet conditions. Let us see a question. A question is, expand the function in Fourier series and show that pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus ... and the function is given by that is f of x is equal to 0 from that of region minus pi to 0 and is equal to 1 from that of region 0 to pi by 2, and the value is 0 from that of region pi by 2 to pi. So how we prove that one? Solution. We have the Fourier expansion. We know the Fourier expansion of the function let f of x, that is a naught by 2 plus summation over n is equal to 1 to infinity a naught cos nx plus summation over n is equal to 1 to infinity bn sin nx. But a naught is equal to the Fourier coefficient a naught is equal to, that is 1 by pi integration of f of x dx from that of region minus pi to pi minus pi to pi. Let me integrate it, that is 1 by pi integration from, that is minus pi to 0, 0 to pi by 2 and pi by 2 pi, that is minus pi to 0 f of x dx plus 0 to pi by 2 f of x dx plus pi by 2 to pi by 2 to pi f of x dx. Since f of x at that of region minus pi to 0, that is 0, here we put 1 by pi is equal to integration from minus pi to 0, 0 dx plus integration from 0 to pi by 2, in that of region that value is 1, f of x is 1 dx plus integration from that value is also 0 from that of region minus pi by 2 to pi. That means this term 0, only that term exists. Therefore 1 by pi, that is pi by 2. Therefore the result will be only half. This is the coefficient a naught. Another two Fourier coefficient as an and bn is to be evaluated. Then an is equal to 1 by pi integration from minus pi to pi f of x cos nx dx Here we take the limits in that of respective range, that is minus pi to 0 f of x cos nx dx plus 0 to pi by 2 f of x cos nx dx plus pi by 2 to pi by 2 to pi f of x cos nx dx. Here f of x is only exist, these two are cancelled, as f of x is 0 in these two regions, only that term exists. Therefore the value is written as is equal to 1 by pi integration over 0 to pi by 2, that is f of x is equal to 1, that is cos nx dx. Here 1 by pi, that is sin nx by n, from that of limit 0 to pi by 2, that is 1 by n pi sin n pi by 2. This is the result of coefficient an. Now bn, another Fourier coefficient bn is equal to 1 by pi integration from minus pi to pi f of x sin nx dx. Here we expand that integral from respective ranges, that is minus pi to 0 f of x sin nx dx plus 0 to pi by 2 f of x sin nx dx plus pi by 2 to by f of x sin nx dx. Again in these two intervals f of x is 0, that's why these two are cancelled, since it result will be 0, only that exists. Therefore 1 by pi integration from 0 to pi by 2 f of x is equal to 1, that is sin nx dx is equal to 1 by pi, that is minus cos nx by n 0 to pi by 2. Taking upper limit and lower limit, the result will be 1 by n pi 1 minus cos n pi by 2, taking upper limit and lower limit. So we now find the values like a naught, an and bn. Therefore that function will be f of x a naught by 2, that is summation over n is equal to 1 to infinity an cos nx plus summation over n is equal to 1 to infinity bn sin nx. Now we put its values. Here f of x is equal to a naught, that is half divided by 2 plus summation over n is equal to 1 to infinity an. The value of an is 1 by n pi sin n pi by 2, that is the value of an. We put 1 by n pi sin n pi by 2 cos n pi cos n x, cos nx plus summation over n is equal to 1 to infinity. In place of bn we implement that one, that is 1 by n pi 1 minus cos n pi by 2 into sin nx Now we evaluate that series. How we evaluate? That is 1 by 4 plus, taking n is equal to 1, n is equal to 2, like this. That is 1 by pi sine pi by 2 cos x plus 1 by 2 pi sine 2 pi by 2 cos 2x plus 1 by 3 pi sine 3 pi by 2 cos 3x plus dot. Then that series plus 1 by pi 1 minus cos pi by 2 sin x plus sin x 1 by 2 pi 1 minus cos 2 pi by 2 plus sin 3x by 2 sin 3x by 3 pi sin 3x by 3 pi 1 minus cos 3 pi by 2 plus dot. Just we put n is equal to 1 here. N is equal to 1, n is equal to 2, n is equal to 3, like this. This is the series for that, and this is the series expansion for this term. Now we write here, that is 1 by 4 plus 1 by pi cos x minus 1 by 3 pi cos 3x plus 1 by 5 pi cos 5x. Plus dot. Look here, how is it done? Sin pi by 2 is equal to 1, that is cos x. Here sin pi is 0, that term cancelled out. That term sin 3 pi by 2, that is minus 1, negative. Okay, again that series, that is sin x by pi plus sin 2x by 2 pi into 2 plus sin 3x by 3 pi 3x by 3 pi plus dot. Sin cos pi by 2 0, only sin x by pi, sin 2x by 2 pi cos 3x by 3 pi. Now we rearrange. Therefore the function f of x is 1 by 4 plus, taking 1 by pi as common, that is cos x by 1 minus cos 3x by 3 plus cos 5x by 5 minus dot plus, taking 1 by pi from these terms, 1 by pi, that is sin x by 1 plus 2 sin 2x by 2 plus sin 3x by 3 plus dot. Now we expand that series. Here we use the Dirichlet condition at the point where the function is discontinued. Here, hence at x is equal to 0 is a point of discontinuity of f of x. Then by Dirichlet condition, f of 0 minus 0, that is the left hand limit is 0, and f of 0 plus 0, that is the right hand limit, is equal to 1. Therefore, at f of at 0, that is half of left hand limit 0 minus 0 plus f of 0 plus 0, that is the right hand limit, that is half, that is at f of 0 we found the value is 0. Now putting x is equal to 0, putting x is equal to 0 in the above series of f of x, that is that series, and equate to and equating to half, we get, that is f of 0 is equal to, here all these terms are cancelled since sin 0 is equal to 0, that is 1 by 4 plus 1 by pi, 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 dot dot dot, which implies f of 0 is equal to half. Half is equal to 1 by 4 plus 1 by pi of 1 minus 1 by 3 plus 1 by 5 1 by 7 dot dot dot, which implies half minus 1 by 4 is equal to 1 by pi of 1 minus 1 by 3 plus 1 by 5 1 by 7 dot dot dot, which implies, that is 2 minus 1, that is 1 by 4 is equal to 1 by pi of 1 minus 1 by 3 plus 1 by 5 1 by 7 dot dot dot, which implies taking pi to that side, that is pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 dot dot dot, that is proved as we write in that of question. This is the question, that function is given in that of region to prove that equation. We take the Fourier series and evaluate its Fourier coefficients by using proper formula an, bn, an, a naught, an, bn, and putting it in that of Fourier series and expanding this series take the discontinued point, that is x is equal to 0. Using Dirichlet condition, we find the left hand limit and right hand limit, and putting we found that, and now we equate that equation putting the values f of 0 is equal to half and evaluate it at x is equal to 0, and we finally prove that equation. So with the help of this video lecture, we understand the concepts regarding Dirichlet's conditions, and using that condition we explain a numerical problem. So with this useful and informative notes, let me wind up this session. Thank you.